Hi everybody, it's Meteorologist Joe Cioffi and everybody's favorite cat, Kovu, who decided to join us tonight, right? All right. So I hope everybody had a great day today. We are going to take a look at what is going on with Jose, and we're also going to look at the day-run European, which by now you've probably heard was quite interesting to say the least. And from what I'm seeing from the new GFS run so far, it might have the better idea of what is going to be happening early next week. But first, let's look at the current loop of Jose. And the Hurricane Center did up the winds to 80 miles an hour based on the satellite loops tonight. Looks like a fairly intense, it almost looks like this amorphous blob of intense thunderstorms, but the center looks pretty well tucked in under those thunderstorms, and there's a little bit of banding that's noted, so they decided to nudge up the winds a little bit. Also, in terms of the movement, they're saying west at 3 miles an hour. Whatever the movement is, it's very, very slow, and that is going to continue during the overnight and into the day on Thursday. Now, just a couple of things with respect to what we have on the forecast. I want to show you the forecast tracks. Well, I was going to show you the forecast tracks. They suddenly disappeared on me. There we go. Here are the forecast tracks from late this afternoon from the Hurricane Model Track Guidance. And you'll notice now some of these don't go out far enough, like these 4 models here, which are the furthest to the left. And then, of course, you have this one that's doing this loop that goes back westward, somewhat like what the European did, and then drops it southward and then turns it out. And then you have a number of models that basically do what you would expect in a situation like this, is to turn it north and then northeastward and go out. But there's a lot of things going on in the upper air, and the primary differences between the European and the GFS after Monday of next week are monumental in terms of what the outcome would be, because one model outcome, the GFS's model outcome, into the middle of next week would suggest that this thing, Jose, will be kicked out to the northeast eventually after making a move up the East Coast offshore. The European, with a different upper air look to a large degree, would suggest that it would turn to the left and go westward rather than eastward. And that difference is in how the upper air is going to be structured. So I'm going to just run this video, and you guys can just take a look at that, and we will then come back and yap for a while, and we'll see, we'll discuss some more, and we'll look at the new GFS, which should be out, I would hope, far enough that we could maybe come to some sort of conclusion, conclusions tonight. So just hang on 1 second and we'll get it going. We're going to start tonight with the European model run from Wednesday afternoon, which was a rather important model run in terms of what it showed and how it gets there. And I'm going to try and illustrate to you the differences between the European, which would lead to one solution for Jose, and the GFS, which would lead to another. So we're going to start with what the upper air looks like for Thursday morning. So you have the remnant low, that is Irma, and that is producing a southwest flow up the East Coast from the Carolinas. Actually, it runs all the way down. There's troughing all the way down into the Western Gulf. So you've got a southwest flow that runs from the Gulf of Mexico up the East Coast into the Northeast. You have a ridge of high pressure, which we'll outline that for you in blue. And this is the ridge, the upper high, that's beginning to build, kind of a finger. And you just can kind of see a nose of the other side of that upper high on the edge of your picture coming in from the Atlantic. And then, of course, you have the what happened? Why did it stop? Okay, there we go. Technical issues, folks. So let me just circle Jose for you. And there's Jose. Now, for the first time in the last couple of days, Jose has now completely separated itself from Irma. When we look back at all this, and just roll back for just a second on the European map, if it ever lets me. So if we roll back here, you can see that Jose is sort of attached to Irma here to some degree, but then separates itself as Irma begins to move to the northeast and that ridge builds in between. So now we are at Saturday morning. And let me just back up a little bit. This is for Friday morning. And at this point, what we have is the remnant trough from Irma now is getting very weak. You've got this southwest flow that's running from the northeastern Gulf up to the Carolinas and then out off the New England coast. Then you have Jose, which is right here. And in between the two, this narrow ridge that you see, and it's right in here. I'm supposed to make that blue for you. Here we go. So there's your narrow ridge, and this is your upper high. So Jose is basically being steered by that upper high. Now we watch Jose as it punches through that ridge. The ridge opens up a hole and weakens just enough, thanks to that troughing that's still left along the east coast, very weak. But what the European did, there were two things going on with the European. It leaves that weak trough behind, and then that trough begins to kind of, I wouldn't say necessarily merge with Jose, but it's certainly impacting it to some degree, hurting an influence. And you have another the ridge up in the eastern part of the United States is actually building up into eastern Canada. And that's because you have a trough of low pressure in the upper atmosphere that it's being evil with me today. I'm not sure why. You've got this trough right there. So here's your mess that's with Irma, with the leftover trough from Irma, once again exerting an influence on Jose. Now what the European does as we go into the longer haul is that ridge builds and Jose just basically gets captured, rotates around, and now as we move into the middle part of next week, you've got this upper high that starts to build in the western Great Lakes, and you can see it here, okay, right in there. So Jose is going to respond to that by actually moving toward the west and then the southwest, which is really unusual. And you could, and then it winds up pulling inland somewhere over Chesapeake Bay as a weaker feature, and again, all being steered by this suddenly this upper high that the European has made up in the northern Great Lakes. So the flow is actually, and you don't see this too often, but the flow in the Northeast and the Mid-Atlantic states is basically coming from the east. So Jose winds up doing something like this in terms of the track. Now, almost like the shape of a question mark, coming in from the east. Now, what is the difference between this and the GFS? The GFS from the day run, and I'm going to switch to the surface so you can see what the surface did on the GFS. The GFS, which is now the new one, this is what happens when you cut videos after a long day. Here's the GFS from the day run. It brings it up northward, and this would be probably the point where it would swing it back westward like the European did. Instead, it kicks it out to the east. Well, why does the GFS do that? Well, let's look at the upper air, and I'm going to widen out because this was really where the differences between the European and the GFS become very wide. There are a couple of things going on with respect to both models. The most important thing, I believe, is this deep trough that's coming into the west, right there. I like to do troughs in red. So there's your deep trough that's in the west. Okay, you have a deep trough out in the middle of the Atlantic. You've got your ridge of high pressure starting to build on both sides. And it's that deep trough in the west where the differences lie, because the GFS swings that trough around, and if you'll notice, as we get into Wednesday and Thursday, you've got this big vortex that drops down almost to North Dakota. This is actually going to be some fairly cold air. They probably will wind up seeing their first snows in some of the higher elevations in Wyoming and Montana out of this. Okay, and you've got this big ridge in the east. So here's your ridge. Okay, and here's the trough in the west, and the jet stream that goes like this, and then you have this trough that's off the east coast. By this time, Irma on the Jose on the GFS is long gone. Now look at the difference between this, and I'll back it up one day. We'll go to Wednesday, and then we're going to switch to the European. That is a big difference. The trough on the GFS is like this, with the ridge in the east, and the European, on the other hand, is, well, hello. European, on the other hand, the trough is more this way, and in fact, more of the energy is concentrated in the European in the southwest. That allows this ridge in the east to really build up strong, and instead of kicking it out, it drives it back westward and southwestward. That is really where the big difference lies between the two models. Now, in my opinion, judging from what we've seen in terms of the overall pattern, the GFS's look in the upper air like this, that look on the GFS to me doesn't smell right. Okay, the European's view, I think, has a better look to it in terms of what might be more realistic. Now, when we look at the European on the surface, and I'll get you the tight view. You can. I'm going to put the surface map on of the European. We'll back it up so you can see how it moves everything. And there it is. It goes north, northeast, then north, and then turns it west and weakens it. Now let me say at this point, if this were correct, and I'm not saying it is, because I think the models are going to be adjusting and changing. One among other things we're going to be looking for during the next 2 days is whether the European's view is correct, or is the GFS going to be more correct, because then the outcomes are totally different, obviously. If the European is correct, what we will probably see would be a hurricane, and once it starts moving westward, it's going to be getting into colder water, and it's not moving westward at any great speed either. So it is very likely that if this comes in the way the European has it, and I don't know that it will be this way, you would have a weakening hurricane to a tropical storm to a tropical depression, okay, as it comes westward. Now, it would probably mean that you would get tropical storm force winds out of this, and the impact that I think would be important is the tides, because of the fact that the swell action up and down the East Coast has been endless since Irma was around. So the water is already high to begin with. The other thing is, on Wednesday we have a new moon, so that is going to have an impact if this is correct. But remember, if we wind up with an upper air that looks more like the GFS, and we'll show you the GFS's view, and the GFS has a fairly well-developed system here. I keep jumping to the new run, which is not out far enough. But if we look at the GFS, they're almost the same up until this point, because now we are at Tuesday afternoon. But because of how the upper air is structured, the GFS acts as a kicker and kicks it out to the east, and the European brings it back to the west. And if the GFS winds up being like the European, the same idea holds, that you would have a weakening system as it comes westward, where the biggest impact would probably be with respect to tidal flooding, if it happens. As it is, either track, but certainly if it winds up being an out to sea track, tides are going to be an issue next week with the new moon coming in. So we'll look at the new GFS run in just a second. Just give me a chance to switch over, and we'll take a look at what the new GFS run has done. Okay, sorry about that. So when we look at the new GFS run, which I'm going to put out right now, the important thing is not necessarily that it follows the European exactly, because there's still time for it to catch up, but whether it's trending in a certain way. And you're going to see when I show you, because I looked ahead of it while the weather part was running. I did look ahead to see what it was doing, and you can see the severe storms map in the meantime. Okay, so we'll get the GFS loaded here and going. And let me punch it up for you. We will put the correct region so we can have the eastern U.S. view, which is going to be very helpful here. And I will use we'll use the precip moisture one first, okay? And here's the new GFS. And you can see it makes that turn, goes north-northeast, then northward, and then it's still trying to kick it out to the northeast, okay, at this point. But here's the thing. Let's look at it here. This is the GFS run right now, and I'm going to go back to the day run today, and you're going to see where it has the low. It's much further. It's much further west, and that gap of being much further west actually gets wider as you go further north. So when we go back, this was one run. So let me go back 2 runs. 2 runs. Current run. See the difference? Okay. Let me do that again for you. Okay. So that is the 2 runs ago, and now we are going to look at the current run. I'm sorry, didn't catch. That's 2 runs ago. Current run. You see how much further west it is? It's almost 5 degrees further to the west, or 300 miles. Now, we'll move it up a little further north. When it's just east of North Carolina, south of Nantucket, okay? There's the new run, 2 runs ago. Back to the new run. All right? The GFS is trending westward. It isn't quite like the European, because it does eventually kick it out to the northeast, but it's going in the direction of the European. So why don't we just look at the upper air again, because that was where the biggest differences lie once we get past day 5. And again, big difference still in the upper air. The GFS still is not making the ridge in the same way that the European is, okay? This is for Wednesday morning on the GFS. Look at how the upper air is structured, okay? And then look at the European. Big upper high here, okay? Back to the GFS, no upper high. There's actually a trough there on the GFS, okay? The ridge is flatter, more south west northeast oriented. You go to the European, and the European not only builds a big upper high that basically acts like a block, and the European responds to that by taking it southwestward. Okay, the GFS doesn't have that. Okay, and it gets kicked out to the northeast. And as we go a little wider, I'll go to that North America view. The big difference is how the models handle the west. Okay, Wednesday morning, big upper low sitting in Montana, European. Look at the difference. All the energy is piled down into California, into the southwest. It changes the whole orientation of the jet stream. The European's orientation of the jet stream is really completely different from what the GFS is. Back to the GFS for the same time, bingo. Totally different because of how it handles the system coming into the western part of the United States. The models are having difficulty with this. And, you know, frankly, we really don't know which one is right. But the fact that the GFS is trended westward, to me, is maybe suggestive that the European might be closer to the truth. And another possibility through all of this is the fact that the two models may wind up in some sort of a compromise, where it becomes the nearest of near misses, and we'll have to deal with whatever that brings about. Let me just show you let's go back with respect to the model. I want to go back to the eastern part of the United States, and let's look at the 10-meter wind. And by the way, we're not obviously at this point, because it is only Thursday here, we're not going to get an answer for this for another few days at least. So look, the wind field gets very close to the GFS of the coast. So the green areas, the sustained winds are the yellows. So the gales are offshore, actually touching parts of eastern Long Island and southeastern New England. So that's how close it gets on this run. And this is far closer than the prior. If we go back 2 runs here, if we go back 2 runs, and you take a look at the 10-meter wind field. The gales aren't even close. Okay, so right now, based on what I'm looking at, and you know, with this model run tonight, it certainly is going to mean for a rather interesting European run to see if it continues this idea of this big upper high building over the Great Lakes and essentially acting as a block and forcing the system to turn westward and southwestward, and eventually going back inland. Now, there have been a few cases going back where we've had something like this. Actually, in some ways, Hermine from last year comes off the North Carolina coast and goes out 200 miles to the northeast and then loops back. But that is a different scenario because it actually came out of the Gulf of Mexico and rode up just along the coast, where this one is actually coming in from the southeast, from the Bahamas, and then riding up northward. So there's 2 different approaches here into how the systems are coming up. Among the things we don't know, by the way, are intensity. What kind of a system are we dealing with? It's a minimal hurricane right now. There could be some things happening in the upper atmosphere that might allow it to strengthen a bit, sort of the way winter storms strengthen. It's called baroclinic strengthening that would happen. That's a possibility. That happens sometimes with these systems. They kind of get a little, I wouldn't say they necessarily get hybridized, but you know, they do change from the pure tropical structures that you see down in the deep tropics when they get up into the northern latitude. So they start to get influenced by other upper air troughs swinging around that could energize them, or in some instances, you could wind up just affecting the structure and making them extra tropical. This does not appear to be the case here, at least not at this point. So we don't really know exactly what we're dealing with here. Again, in theory, if it comes in from the east the way the European has it, you would wind up with something that would weaken as it comes westward. That may not necessarily lessen impacts with regards to tides, because I'm still thinking that that's where you might get you might wind up with the biggest problem out of this, if this is right. Again, we are still very, very much in the speculative phase here of what's happened. There's nothing here that we can definitively say is going to happen one way or the other. But I think the model run tonight of the GFS certainly suggests that you're going to have to pay attention to this over the next couple of days before we can kind of have a good idea one way or the other which way this is going to play out. Let me just see if the Canadian run is out. And oddly enough, the Canadian model, the old broken clock model, had this looping idea like the European did a day or two ago, and we kind of scoffed at it. And I'm going to show it to you because it actually does look more like the European than it does the GFS. It almost looks like a compromise to a large degree. It almost looks like a compromise between the two. So let me pull that up for you at this point, and we can look at the Canadian. Write this date and time down that Joe was putting the Canadian model up. And let's interact so I can change to the Canadian. And here we have it. Look at the Canadian model, and it really, in a way, it's sort of a compromise of the two models. Turns northeast and north, then northwestward, and then winds up going out to the northeast after that. So you are, it's an interesting run actually, the Canadian model, because it does sort of split the difference between the two. And then out it goes. And the Canadian model, by the way, is faster with all of this. That's the other question to me with the system down in the Bahamas the way it is. That being that we're now into early Thursday, it would, maybe this will all play out a bit faster. That's another thing to consider here. So we'll have to, I think we're going to have to pay attention all the way around. And you can see how the wind field gets pretty strong offshore with 40 to 50 knot winds, actually touching the New Jersey coast and Long Island and southern New England with this, if the Canadian was correct. So no closer tonight, at least so far, in coming to any sort of conclusion, but certainly there's certainly, I think, enough here to start having some, putting up some red flags with regards to what may happen here early next week. There certainly is enough evidence, in my view, to start thinking in those terms. Now, again, in terms of specifics, you're not going to be able to do that now. So, if you're going to ask me if it's going to hit a certain point at a certain given time, that I can't answer that question. And but you at least you got to see what the upper air looks like. And I know, Anthony, you have a better chance of hitting a superfecta at the horse track than the Canadian being correct. I'm just suggesting that the Canadian, in this instance, almost looks like a compromise between the GFS and the European. I don't think you can really discount it completely, that you could wind up with something like that. If the European, for example, if it's wrong on that upper high building, then it may wind up being more like the GFS, but maybe the GFS is wrong by having that trough in the west so deep where it barely has a ridge showing up in the east, and so you kind of split the difference between the two. That's how I'm seeing this right now. That the Canadian basically splits the difference, and 99 Wolves. I usually, I don't look at usually if I look at the Canadian, I look at it last. In a situation where I can't seem to resolve the two extremes that both models are having. Tonight was one of those nights to see if it would at least maybe give me some kind of an idea. And I think it was actually useful to look at it because of the fact that it does split the difference between the two. So you still have kind of the wide range where the European is the furthest west, like it was with Irma, and the GFS was the furthest east, like it was with Irma. And maybe the answer is going to be somewhere in between. Oddly enough, by the way, while the European was better with Irma in the longer time frame, the GFS actually was better with Irma in the shortest time frame because Irma did wind up tracking further east than the European model did by not many miles, but it was a significant enough number of miles to change certain outcomes in Florida and most of that was apparently to the upside because it did at least reduce the storm surge. So we're going to, continue with this. I think we're at the pay attention phase at this point. Zachary Grybos, the two waves coming off the African coast. Okay, well, since you asked, I haven't even looked to see what they look like, but I do have the loop, so we can look at them. So let me punch those up for you. And here's the Eastern Atlantic satellite loop. So you can see there's the two waves. There's one that's coming off the African coast now, and then there's one that is well southwest of the Cabo Verde Islands that actually doesn't look too bad at this point. It looks like there's a fair amount of convection, and it's got a bit of an arc to it. So and I believe the GFS, the two runs today, did actually try to develop something out of that, although eventually it winds up losing it. We can look at, we'll go to a wider range here. I'll put the North Atlantic view up, and we can take a look to see if it does anything with those, since you guys are asking when you have some time. And indeed, it does. Looks like it does do something. So let's roll it back. And all right, so we are now. Let me make sure I got the right time frame here. So, okay, so here we are. This is Thursday. You can see there's a low out there in the central tropical Atlantic. So it does apparently develop that. But notice it's already moving northeastward and northward out into the central Atlantic. And it would have to do that because there's a trough that's going to be, you've got a ridge in the eastern part of the United States. So when we look at the upper air here, there's probably a big hole in the Atlantic. And indeed there is. You can see there's a deep trough that runs from Greenland all the way south, cuts the Atlantic almost in half. And it would suggest, at least on the GFS's view, that it gets caught by that, some kind of little upper low that's sitting in the central Atlantic there, and it gets pulled up northward from that. Now, the European today actually took it all west and west-northwest right through its forecast period. So maybe the GFS is wrong on the look in the central Atlantic. I don't think we're going to know too much about that. Does the Canadian pick up on it? And in fact, it does. It's actually not that different from the GFS. So here's the GFS's view, and here's the Canadian's view. And they're not that, their 500s are actually fairly similar. I think where the difference lies, at least with respect to why it pulls Jose further northwest on the Canadian, a little bit more northwest than the GFS, is because it looks to me like the trough the ridge might be a little bit stronger, and the little less troughing up in the upper Midwest with that jet stream that runs southwestward from the southwestern U.S. on up into eastern Canada. So it's a slightly different structure that perhaps is the reason why it has a more left track with Jose. So interesting that they really the GFS and the Canadian are not that far apart in terms of their overall view. So we're going to have quite a bit to look at, and I'm not staying up for the European run, so I'll have to look at it when I wake up in the morning. But certainly, again, we can see that we're going to have to watch this very, very. We're going to have to watch this closely. The Europeans run, if it does the same thing it did in the day run, again, I would then guess that you're going to see the other models perhaps come around more to that idea. But how that upper ridge builds in the Great Lakes and into southeastern Canada creates almost sort of a block. That is going to be very important. And again, in instances like this, 99 Wolves, you bring up a good question. What's the percentage of hitting the East Coast of systems? You know, if we're talking about systems coming in from the east or the southeast. There have only been a few. There have been some. There was, the one that is different from this, but Hurricane Ginger, I believe that was sometime in the 60s. Maybe it was 69. Hurricane Ginger wound up going off the North Carolina coast, went straight east, almost to 40 degrees west. I mean, way out. And then wound up turning around and coming all the way back and eventually going inland as a weakening tropical storm into the Carolinas days and days later. So, I mean, there have been some odd tracks over the years. Every once in a while, you do get some that do strange things up here in terms of looping, in terms of coming in from off the ocean. But most of the time, when we have systems that are tracking, 71, thank you, Anthony. Most of the time, when you get situations like this with the upper air, similar upper air, you wind up having them get kicked out to the northeast. So the out to sea solution statistically will probably, is one that you would bet on more than the west motion, if only because of the fact that there could be even the weakest of troughs that the models are not picking up on that could wind up causing this to turn. We saw that last year with Hermine because of the fact that even in the short range, the models were off. That Hermine wound up moving out an extra 150 miles to the east before it started to make its turn back northwest and westward. And that 150 miles made every difference in terms of the outcome, in terms of the tidal flooding, in terms of the rain, the wind, and everything else. So, these things are very important. This again is an example of the fluidness of what we're dealing with. And it's indeed, this is about as fluid a situation as you're going to have because of the possibilities of all the different outcomes. And by the way, the UK Met model continues to be way to the left of the new UK Met. Is way to the left of the GFS and the Canadian, and it was actually even left of the European because it took it in eastern North Carolina. So there's your real outlier in terms of the west track. But remember that the UK Met did pretty well with Irma, so we want to be careful, and we want to have we're going to want to keep a lot of options open. So as I figured, nothing would be resolved tonight, but we're getting some clues, and let's wait to see what the day runs bring us. I think we're gonna be probably into the weekend before we can really kind of cinch this all down. So let's not get too worked up or too excited at this point, and we will re-examine things later tomorrow. Hurricane Bell, I believe, was 76 or 77. 77, I believe, was Hurricane Bell. That came from the Bahamas, came up the coast, and by the time it hit Long Island, by the way, it had weakened to a Category 1 because of the cold water. It never really accelerated the way it was thought to. These things have to be moving up here at 40 to 50 miles an hour in order to compensate for their time over the colder water. That's the only way that you wind up having something really strong, like the 38 hurricane, for example, which was moving at rates of like 60 to 70 miles an hour when it hit Long Island. So you're not going to have that in this case. You're going to have something that's going to just basically be creeping along over 70 to 75 degree water that's south of Long Island and east of New Jersey. So you could have every bit of a Category 2 hurricane sitting out when it's east of 70 west, And by the time it gets to the New Jersey coast, if it were to happen that way, and I'm not saying it is, I'm just giving you an illustration. By the time it would get to the New Jersey coast, it would have already weakened to a moderate tropical storm. That changes a lot in terms of what you're going to get as far as weather is concerned. But those are the parts of the equation that we are going to figure out once we have an idea of exactly what we're dealing with here in terms of the final track. And again, I don't think we're going to really know that at all until we get into the weekend. So I'm just going to scroll back on your comments. First of all, a big thank you to everybody that's here tonight. I really appreciate it. And Sharon Ann Thomas, yes, disaster fatigue for sure. But this at least does not look like, we're not dealing with a Category 4 or 5 hurricane here. Okay, so let's make that clear. This storm at the moment is nothing like the other two, and odds are it will never achieve that kind of strength moving up the East Coast, because the water north of 35 degrees north, while supportive for tropical storms and hurricanes as long as it's offshore, is not really terribly supportive for Cat 3s. It might be on the edge of one, but and I'm not saying that this one is going to get there. We have to see how this reacts as it moves further north. I mean, if we were sitting with a Cat 5 right now sitting there, or a Cat 4, then I would say, okay, we're dealing with a fairly strong animal right at that point. But we don't have that. We have a Category 1 with 80-mile-an-hour winds. We have upper air conditions that are not exactly the most favorable. We have a system that's actually moving over water that it's already moved over and upwelled, so those water temperatures have been cooled by at least a few degrees. That's going to have an impact on how much strengthening that's going to happen. And again, if the upper air isn't right, you could wind up with a minimal hurricane that moves up and then weakens fairly quickly to a tropical storm as it moves westward. So, and of course, the Europeans' view puts angle of approach into play, and the fact that we have a new moon. So that's another part of this equation, assuming that it winds up being the correct model with regards to this, and we don't know that is yet the case. Let's see, just a few more of your comments. Gene and Ginger were both storms that were bizarre because of the upper levels in the Bermuda High. Jose is acting just like them, and these storms lingered and wouldn't die. I think you have a very good point, Tornado 1994. Yeah, this is a bit of a bizarre situation. Michelle Leota, thank you for being here. I appreciate that you enjoy my YouTube channel. Let's see. And Michelle, the storms this year are unpredictable. They're very hard to predict, certainly, and that will always be a constant in every hurricane season. Every hurricane is difficult to predict in terms of everybody wants to know the exact outcome, and you just you can't do that. We don't know that. We can give you generalities of what we think you can expect, and there's going to be variation from place to place and from time to time. I think I think Irma certainly proved that on the Florida coast. Harvey to a lesser extent in Texas, because it was pretty evident days before that rain was going to be the real killer in that storm, even though it did do a lot of wind damage at Rockport, Texas, and along coastal areas. But it was the rain that really that Harvey is going to be remembered for, more so than its strong winds. It'll be remembered for its winds where it came in along the coast, but for the greater population, and especially those in and around the Houston area, it's going to be the rain. And J.S. Sweetie wants to skip all of this and move on to a few feet of snow. We kind of got hosed in snowfall last year, and I'm ready. Well, you know what? Before you know it, we're into almost middle September, so another 4 or 5 weeks, and we're in through the middle of October. After that, if this hurricane season behaves like most do, it will wind down fairly quickly after the middle of October. But who's to say? Stranger things have happened. But at least from the standpoint of when we're getting everything happening in terms of the peak activity, that's at least playing according to climatology so far. We are having an above average season. We are on the verge of having our 12th named storm if we wind up getting Lee at some point over the next 3 or 4 days out in the tropical Atlantic, but we'll see. If we had a normal season, 12 would be a good number for the whole, the whole thing. It's moving. Climatology, at least from the standpoint of timing of when we're getting those peak storms, came just about at the statistical peak date, which was on the 10th, and we're now at the 14th. Usually, after a peak period like this, don't be surprised if we wind up getting a bit of a lull for a week or two, and then we'll get another little burst of activity maybe in the first couple of weeks of October before we finally get that wind down. All right, folks, let's call it a night. Time for bed. I will be back tomorrow. I'll stream something around noontime, so we'll have the new GFS run in, and we'll go over the overnight European model to see where that takes us and see if we can get any more clues about what may or may not happen with Hurricane Jose. I hope everybody had a great day, and I want you to all have a terrific Thursday because we're 2 days and dropping as we get toward the weekend. And at least up here, the weekend is going to be nice. No matter what Jose does, Saturday and Sunday look like 2 really nice days with sunshine, and I'm looking forward to that. All right, have a great night, folks. We will talk to you Thursday noontime.